another F word of math. First one of math F words we hate, fractions. The second F word, functions. Be careful when you say that, okay? That's funny, okay? A function is a relationship between the input and the output. In a function, there is exactly one output for each input. There's exactly one output for each input. In other words, your x values can not repeat. Your x values cannot repeat in order for it to be a function. So yesterday we talked about mapping. Shows our domain, shows our range. Domain is your x value, range is your y value. In relation, in relation 1, do any of my x values repeat? How do you know?
The letters are the same.
No. Do any of my x values repeat?
Oh, the arrows don't go the same.
Bingo. There's only one arrow coming out of every domain. So this, yes, is a function. Yes, a function. Look at relation 2. Is this a function?
No.
Why not?
4 and -6 go to -7.
Do I care if the range repeats? I don't care if the range repeats. It's all about the domain. Are there 2 arrows coming out of one domain? So is relation 2 a function? Yes. Now they swapped. Now we're not talking mappings. Now they gave us ordered pairs. Is relation 3 a function?
No.
Why not? Which? Ooh, very good. I thought J and J are the same, and X are the same. So not a function. Relation 4. Why not? Zeros are the same, so not a function. So they may give us a mapping, they may give us ordered pairs. All you're looking at is, do I have an x value that repeats? Now another way of doing this, given a graph, is called the vertical line test. Vertical lines run up and down, okay? Vertical lines run up and down. I'm going to pretend that this yardstick is like your pencil, okay? So all of you have a piece of paper laying on your desk, yes? Just like my projection screen. If you lay your pencil down like this, lay it down flat, okay? A vertical line test says if a vertical line intersects, what does intersects mean? Crosses the graph more than once, then it's not a function. So if I take this and I start sliding your pencil across this graph, at any one time, is it touching the blue line or the blue curve more than once? No. So this, yes, a function. If we go to the next one. If I have my pencil as a vertical line, is it ever touching the graph in more than one location?
Yes.
Here, see that? How it's touching down here as well as up above. So, is this a function? No. Now I want to talk about this for a second. If I just pick this point right here, these two, like that's where, if I would have a vertical line, right? This point would be 0, 3. And this point would be 0, -3. Look at your x values. They're the same. That's what we talked about up above, right? If you have a repeat x value, it's just like failing the vertical line test. Okay, how about the last graph? Here you're good, right? Right on the end of that. But here, not so good. Function, yes or no? No. Because if I have a vertical line right here, is it touching the graph more than once?
Oh, yeah.
Right here and right here.
6 and 4.
A repeating one.
Yeah, there definitely is.
If you hold this right here, is your blue line going through my ruler more than once?
Oh yeah, it's going through it.
Then it's not passing the vertical line test. Okay, so let's make points up. Right here and right here. This point would be like 4, 1. This one would be 4, -3.
Oh yeah, I got it.
Repeat x value. Okay, so function is all about your x's. Do the next 3, top of the page, on your own. Does this pass the vertical line test? You're answering yes, a function, or no, not a function. First one, yes or no? Not a function. Anywhere in here, I'm touching the graph more than one time. So not a function. How about the second one? Why not? Very good. This one's fine, right? This one's fine. This one's fine. But you have these two right here. And the last one. Yeah, I think we're good on this one. There's no 2 points right above one another on the same x coordinate. Okay, so the biggest thing with functions is your x value cannot repeat. Do I care about my y value? I don't. I don't care about my y value. It's all about the x value. Then we talk function notation. It's always super intimidating, but it's just a really fancy way of writing inputs and outputs. Okay? Whatever you plug in here is your x value.
Can I sharpen my pencil?
Yes, go ahead. Whatever is inside your parentheses is your x value. That's what they want you to look for under x. Whatever this equals is your y value. Inside the parentheses is what you're inputting for x. What it equals is your output of y. So today they're going to give you graphs. Here's the graph of function f shown below. Function f is just a fancy way of saying, hey, here's a graph that we're labeling as f. It says find f of 0. Because 0 is inside the parenthesis, that really is our x value. They want to know what is f of 0. In other words, when x is 0, where's your graph? 2. Everybody agree with that? At 0, x is 0. Your y value right here, everybody follow, is 2. So f of 0 equals 2. When x equals 0, y equaled 2. Don't tell me it's 4.
I'm not going to tell you it's 4. I'm going to ask how you can take anything times 0 and get a positive number.
You're not multiplying anything.
Dude, you're trying to find a coordinate.
F of 0, function is a graph. It's a label. You're saying in this graph where x is 0, what is y? You're not multiplying anything. This is notation. That's what we set up here. function notation is a way of writing stuff, inputs and outputs. You have no idea what the equation is that created this line. So this one says, here's a different function f shown below. Find one value of x for which f of x equals 2. Let's take this one first. F of x equals 2. So they're telling us, according to this, our y value is 2. They want to know, what is the x value when y is 2? Y-axis is here. If I go to 2, it crosses my graph here as well as here. That's why it says find one value of x. Technically, there's two different answers here. Okay, x could equal 1, or x could equal 4, and y would equal 2. On the flip side, they want us to find f of 3. 3 is our x value. They want to know, what is the y value? When x is 3, y is -4. How do I know that? X is 3, so I go to 3, go down to my graph, and I liked Maddox's way of saying it's literally you're looking at coordinates. 3, -4, x, y. You're reading a graph. What you have to remember is inside the parentheses is your x coordinate. Outside, or what it equals is your y value. So this also can come into play when they start talking. We can use function notation with equations. So Austin purchased a prepaid phone card for $15. Prepaid phone cards are like gift cards. Calls cost 8 cents a minute using the card. The credit, C, left on the card after it's used for X minutes is given by the following function. So they wrote this for you. They're saying what's left on the card is calculated by taking $15 minus 8 cents times every minute. They're giving us to us. I want to know how much credit is left on the card after Austin uses it for 40 minutes of calls. How can I figure out how much is left on the card if he makes a 40-minute phone call? Jackson?
Substitute that the x for 40 and take 0.08 times 40.
Very good. Main thing to start on this is just understanding that 40 is what x stands for, minutes. And then at that point, you're looking at your PEMDAS, right? So $15 minus 8 cents times 40. I like your vocabulary of substituting. Substitute 40 in, and then you told me to take 8 cents times 40, correct? Which is $3.20. Am I right with that? Then if I subtract $3.20 from 15, $11.80 remaining. So functions, just understanding your x cannot repeat, is the whole first portion of today. But the second part is reading graphs and understanding notation, reading carefully. Now, there's probably very little work to show. These problems, yes? Can I trust you to do that and not require you to turn work in?
Yeah.
Okay. You have functions online due at 8 a.m. Go to it.